Now here in problem number 27, we're given this rational expression to be divided by this one, so it's a division. So what we're going to do is we're going to invert the divisor and change the division to a multiplication. So let's do that now. And just like magic, I did that. So all I did was I changed this to a multiplication and inverted this. So let's see what we can do here. I think we can cancel a few things. First of all, I've got this. Oh, you know what? Before we cancel, look at this. We can factor down here. So let's do that. I'm going to rewrite this whole thing with this binomial factored. So we're going to have x minus 8 squared over 2x cubed times 6x to the fourth. And here, a 3 and a 24, we can factor a 3 out. And doing so gives us an x minus 8. And what do you know? It just happens to match one of those. So let's start canceling what we can here. Now, I've got two of these x minus 8s in this numerator and only one down in that denominator. So this one here will cancel with one of those. And now this 2 will go into 6 3 times. And down here, I've got 3 x's, and up here I got 4. So all 3 of these x's will cancel with 3 out of 4 there. So I can cancel all 3 of those with 4 there, leaving 1x. So now, being careful not to lose anything, what we've got here is I've got that 3 and an x, and that x minus 8. So let's write that. We're going to have a 3 and an x minus 8. Oh, I see something else now. And in the denominator, everything canceled except that 3. I didn't see that before, so over 3, and now I see it, so now I'll cancel those 3's. So I'm left with this, x times x minus 8. Now here in problem number 33, we're going to divide this expression, this rational expression, we're going to multiply this expression by this one. And we know how to do that. What we're going to do is we're going to factor everything in sight. So let's do that first. And then if we see any common factors, we'll cancel them. So let's see what we can do here. We can take a 7 out of here. And doing so, this will give us 7 and x minus 3. And in this denominator, we can take a 3 out. So let's divide. Take a 3 out, and we're left with x plus 3 times. Now, up here, we can take a 4 out. So if we remove that 4, we'll be left with an x plus 3, which we can now see is going to cancel with that one. And in this denominator, we can take out a 6. Let's do that. Take that 6 out, we're left with x minus 3. So what's going to cancel here? This x minus 3 with that one, this x plus 3 with this one. And now what else can we do here? Well, the 7 and the 3 I can't do anything with. The 3 and the 4 I can't do anything with. But the 4 and the 6, we can divide a 2 out of those. So if I do this, 2 will go into 4 twice. 2 will go into 6 3 times. Now I just need to be careful that I don't lose anything here. So we are going to get 7 times 2, which is 14. Everything else is gone, so I'm going to get a 14 here. And in the denominator, we're going to get 3 times 3. So I'll get a 9. So there we go. In problem 39, we're given this trinomial divided by this trinomial, and we're going to divide the whole thing by this expression. Now, this is a division, so I know I'm going to invert this. So I'm going to rewrite this whole thing, but as I do, I'm going to go ahead and factor this, save a step. So let's factor this numerator right here. So we are going to get, okay, let's factor. So we're going to get a z and a z. And then what do we want to use here to get that 63? I'm thinking a 9 and a 7. I can kind of see it over here too. That's a hint. A 9 and a 7, I can get a 2 out of that. So how about a 9 and a 7? The 63 is negative, so these two numbers are going to have opposite signs, and I'll put that middle minus sign with the bigger product. Inner is 9z, the outer is 7z. This is bigger, so I'm going to put that minus here. Minus 9 plus 7 gives me a negative 2. Over. Let's see what we get here. How about z and z? Oh, you know, I'm thinking we're going to see 49. How about a 7 to 7? I can get a 14 out of that. So z minus 7 times, right? It's a division, so I'll change it to multiplication. Now take the reciprocal. Right, so flip that over. We'll get z minus 7, z minus 9. And it looks like we're going to get some cancellation here. That z minus 9 goes out with that one. Z minus 7 with that one. And so we're left now with just this z plus 7, right? 1 times z plus 7 times 1. So we're left with a z plus 7 over, what have we got here? Z minus 7 times 1 times 1. So this is all over z minus 7. So let's get a start on number 45. So what we can see here, it looks like everything's factored here except this. Let's factor that trinomial. So we're going to set up our parentheses anticipating we can do this. And how about a y and a y? And for that 30, I'm thinking a 5 and a 6. Here's kind of a hint also. So let's write a 5 and a 6. We'll make the 6 negative, this one positive, right? Negative 6 plus 5 will give us that negative 1. And all of this is over y plus 3 times, okay, y minus 5 over y minus 6. We're not going to get a whole lot of cancellation here, are we? I think what's going to cancel is just the y minus 6's. So we are going to be left with y plus 5, y minus 5, all over y plus 3. And I'm going to leave it like this. I'm going to leave it in factored form instead of multiplying this out. I mean, these are conjugates. You could write it as y squared minus 25. But all in all, it's probably better to have it in factored form.